This is data from an UCO 4.1 captured in Barcelona, Spain, with a ground sampling distance of 7.5 centimeter. So here we see now a huge part of this data set in the 3D editor, where we see a low resolution DSM and the body of water with the overlay of the mask. Now the mask deactivated, so we see here the height of the water as it is in this low resolution DSM derived automatically by the software. So in case that something went wrong with the automated detection of water, there are a few ways how to interact with the data. So first, for the mask, we can use these tools here to modify the mask, so to create some areas to be included in the water mask. So now this polygon here is considered to be water as well. Of course, this is not correct, just to show you this with an example. On the other hand, we can also modify the height of the water. So if you have project requirements where a specific height of the water level should be applied to be used in the DSM, then this can be done very easily with the tools that we have now available. So we use this height brush here, and from my data set, I know that the water level should be 15 centimeter. So now I can draw a polygon around all of that here. And now all of the area which is highlighted by this greenish color, for all of this area, this height of 15 centimeter for the water is applied. And please note, the shoreline is taken into account. So the classification data, so where the water was detected by the software automatically, only for that area the height is applied, but not for the other area, not for the land. This is an incredibly efficient approach because the operator does not need to digitize the shoreline in a manual way, but can rely on the automated extraction of the shoreline and then only do QC and edit the shoreline in case where needed. But otherwise, all this work is done in an automated way. So now switching off the auto overlay, the mask overlay, and this edits overlay, then we can now go back and forth between the original version where water height was estimated by the software, and then after our edit, and we can see that there is now a perfect water level as it is applied to this data set. With just a few clicks, this huge body of water with a very complicated shoreline in this harbor area was modified. And all these modifications are done on low resolution of the orthophoto and low resolution of the DSM. The reason for doing that on low resolution is to make it possible to interact with the data at very large scale. So huge project areas can be loaded into this editor, can be viewed, and can be modified in that way. And doing that in low resolution has the benefit of fast interaction with the data for the user and reduced consumption of processing time. So all this is streamlined to get the data ready for doing then resource-intensive processing on high resolution.